Hello students. After watching my previous video about the electrochemistry where I had discussed about the previous year questions and how to solve them nicely without getting confused or I had illustrated some concepts over there while taking the previous year question. Like after immense response to that video, many students just messaged me personally asking that they want me to strategize some new video in which I'm telling about how to remember some organic reactions. And like students were complaining, they were saying that they were telling the problem that when it comes to the preparation of so many reaction, it becomes difficult to remember. Even if they remember it, they can't present it in the final paper. So the thing is that I may help. I can try helping you out with one strategy which can take at least care of at least 12 reactions, especially from the alcohols, phenols, ethers, and the aldehydes, ketone, and the carboxylic acid topic. If you feel that my videos are adding values to your preparation, it is boosting your confidence with respect to subject, then please like, share, and also subscribe. Please share with your friends also, because this is the only channel so far in Goa which is only made for the Goa board students, and I feel that this is helping the students very much. So please subscribe and share. Thank you. So let's go ahead with the topic. That is today's topic. We'll discuss about this. The thing is, first we'll discuss about the problem. First we'll discuss about the problem. Like what type of questions you can handle when it comes to organic chemistry, or the strategy which I am going to tell you today, which will handle what kind of problem. See, many times the questions are like question is like prepare certain alcohol. They may say, prepare butane, butane, one all from you know certain aldehyde or dash aldehyde. You have to decide the aldehyde. Or the question may be like, they may just give you this reaction. They may just give you this reaction like this, OH. And they will write over here. The question may be like lithium, aluminum, hydride. They may ask you the question, what is the product, major product over there? Or the question may be this also, same carboxylic acid, then uh, sodium borohydride. Many kinds of questions are possible. If there is a ketone, if there is a ketone like this, and you add a reducing agent like sodium and ethanol, okay, then what is the answer? All these kind of question, which includes one thing is aldehyde, then carboxylic acid, any question which includes interconversion of this aldehyde carboxylic acid, then primary alcohol, secondary alcohol, and ketone. Any interconversion of this, okay, you can handle this reaction. At least I'll say that 10, 12 reactions are there total um, in the chapters like alcohols, phenols, ethers, and the aldehyde ketone. You can handle them very easily. At least two, three reactions will be coming for the board. And if you know this one strategy, it will be of great help. So we'll start with the things. I'll tell you the strategy first, then I'll tell you how to apply that. So first is, um, hope everyone knows about what is oxidation. First, we'll talk about the oxidation and its definition, a classical definition of the oxidation. I'll write a simple definition. Okay. Those who don't know the oxidation, they can hear me. Those who know, they can just go ahead. Okay. Oxidation is written as addition of oxygen. This is one of the definition. Addition of oxygen or removal of hydrogen. This is oxidation. What is reduction? Reduction is removal of oxygen, removal of oxygen or addition of hydrogen. Yeah. If you remember it from the 11th standard, these are the two definitions we are learning in the redox chapter. So don't consider organic chemistry as a totally independent. So to learn organic chemistry also, we should be knowing some concepts of the no, inorganic or physical chemistry. So oxidation and reduction, if you know this much about the oxidation and reduction reaction, you will understand what is the next part. Next part, I'll write over here. If you have the primary alcohol, I'll write first. You have to remember this flow chart. Okay. You have to remember this flow chart. Primary alcohol. Okay. If this is the primary alcohol, and if you do the oxidation of primary alcohol, if you do the oxidation of primary alcohol, what you get is aldehyde. And if aldehyde is oxidized further, if aldehyde's oxidation, if you are doing further, then you get carboxylic acid, carboxylic acids. Okay, this is a flow chart. Just remember this. Now, what is a primary alcohol? I'll write a simple example over here. Primary alcohol example is this, right? RCH2OH. This is a primary alcohol. This is how we generally represent primary alcohol. It will get converted to aldehyde, C double bond OH. And further, carboxylic acid is written this way, RCOOH. Now, I have written this is a primary alcohol to a aldehyde. In if you see, this is a oxidation. This is an oxidation happening. Why I'm calling a converting primary alcohol to aldehyde is a oxidation. You see that there is one carbon, there is one carbon. There is R group, there is R group. Here there are one, two, three hydrogens, but here there is just one hydrogen. Okay, one oxygen, one oxygen. If you see the number of the hydrogens over here is less, means there is what? Removal of two hydrogen. We have removed two hydrogen. So this process, which I say oxidation, it is how it is justified? It is justified by this. I can say that it is removal, removal of hydrogen. That's why it is oxidation. Okay. Now you see from here to here, RC, RCOH, that is aldehyde, is converted to RCOOH, that is carboxylic acid. This process from here to here is also oxidation. Can someone tell me? The thing is, it is oxidation because there is addition of oxygen. Extra oxygen is there in a carboxylic acid. That's why this is oxidation. Now, if you ask me reverse, if you do the reduction of the carboxylic acid, what you get is aldehyde. And if you do the reduction of the aldehyde, you get primary alcohol. It is that simple. In this whole process, while you learn this reaction, what is very important is just remembering the reducing agents and just remembering the oxidizing agent. It is that simple. Like more, you have to know what will be the strength. Okay, some reagents are there. If you start with the primary alcohol, very strong oxidizing agents like KMNO4, they directly convert the reaction or the primary alcohol to carboxylic acid, the reaction won't stop at aldehyde. That is the thing. You know, if you take some mild oxidizing agent, it will stop at aldehyde. It is that way. So next is if there is a secondary alcohol. We'll talk about the secondary alcohol also. Secondary alcohol. If you have secondary alcohol and you are doing this oxidation, it will get converted to ketone. Okay. Maximum it can get converted to what? Ketone. So how does the secondary alcohol look? This is how the secondary alcohol looks. This is how we represent secondary alcohol. If you feel anybody feels that you want explanation about what is primary, secondary, tertiary alcohol, you just comment in the chat section. I'll see that if I can make some video on that understanding also. So this is secondary alcohol. The ketone is this. The ketone generated is this. This is the ketone. Now, this is also when you go from the secondary alcohol to ketone, it is also oxidation. And why it is oxidation? It is oxidation because there are removal of these two hydrogen. This hydrogen and this hydrogen is removed, and there is a double bond form. So I can write over here that there is what? There is removal of hydrogen. And if you do reverse ketone, then this is reduction. Ketone will give you a secondary alcohol. So if you can remember this one flow chart, it can solve, it can help you remember many of the reaction. Means for you cannot say that remembering. This is one trick, big trick, which will take care of at least 10, 12 reactions. Okay. So now we have understood this. Primary alcohol gets converted to aldehyde if we do the oxidation. Aldehyde further, if we do oxidize, it gets converted to carboxylic acid. Secondary alcohol on oxidation gets maximum converted to ketone, and ketone on reduction gets converted to the alcohol. This is the one flow chart which will take care of 10, 12 reactions of the alcohols, phenols, ether, and aldehyde ketones and the carboxylic acid. Trust me. This will be like, those students who feel that organic chemistry is tough, can't remember the reaction, all this type of stuff, the students who complain, from today, after knowing this, I'll say that I have solved 20, 25% of the problem about the reaction. This is not only about this reaction, not only about these chapters. You can apply this kind of strategies for the other chapters also. Okay. If you feel that this strategy is going to work, please like and subscribe my channel. So we'll go ahead. So let us make the list of the all the oxidizing agents and the reducing agent which you should be knowing. So first I'll write oxidizing agents and also I'll discuss about their strength. If it is a strong, then to what extent it will oxidize. Okay, and if it is weak, to what extent it will oxidize. I'll also talk about the reducing agent and also their strength. So first, I'll write oxidizing agents. So oxidizing agent, one oxidizing agent, first you should know CrO3. This is a good oxidizing agent. Um, I would say that this is something which can oxidize primary alcohol to aldehyde. Okay, if you refer to that flow chart. It is not that strong that it can oxidize primary alcohol to carboxylic acid. But if you add it one more time on aldehyde, it will convert aldehyde to carboxylic acid. So we'll consider it to be a mild oxidizing agent. Second oxidizing agent, is KMNO4. KMNO4. I'll write acidic medium. Acidic medium. Okay. This falls under the category a strong oxidizing agent. This is strong oxidizing agent. Strong it is. Oxidizing agent. So it can oxidize primary alcohol in between who comes aldehyde, but reaction won't stop at aldehyde. It will get converted directly to carboxylic acid. If you refer to the flow chart, there is a primary alcohol, then aldehyde, and then carboxylic acid. But this is the reagent KMNO4 is the strongest oxidizing agent which converts primary alcohol directly to carboxylic acid. Now, you must be asking, what about the secondary alcohol? Secondary alcohol doesn't matter whether it is a strong or weak. Maximum it can get converted to primary alcohol to a, secondary alcohol to ketone. Okay, so you have to worry only about the primary alcohol. Secondary alcohol will get converted to secondary alcohol will be converted to ketone over here. Here also same. Secondary alcohol will be converted to ketone. So don't worry about the secondary alcohol. There is only one possibility from secondary to ketone, right? Third um, is PCC. PCC. That is pyridinium. Sorry, pyridinium chlorochromate. This is a full form of this. This is also a mild oxidizing agent. Like it converts primary alcohol to aldehyde. Okay. And of course, secondary alcohol to ketone. Okay. One more thing I wanted to discuss about the alkaline KMNO4. I'll discuss below KMNO4 only. To make this third. If KMNO4 is there in alkaline medium like KOH, this is also a strong oxidizing agent. This is also a strong oxidizing agent. Here also, first it will convert primary alcohol to carboxylate ion. Carboxylate ion. What is the meaning of carboxylate ion? I'll just show you. This is your carboxylic acid, OH. Carboxylate ion is this. This is your carboxylate ion, and this is your carboxylic acid. Further, this carboxylate ion on addition of the acid will get converted to a carboxylic acid. Carboxylic acid. Same way, secondary alcohol to ketone. Finally, this is also converting a primary alcohol to carboxylic acid. Okay. Then there comes fourth is Jones reagent. Jones reagent. Okay. Combination is CrO3 and H2SO4. So over here, this is also mild oxidizing agent which will convert primary alcohol to aldehyde. And aldehyde, like whenever I say primary alcohol to aldehyde, it is a mild. Even if it is converting aldehyde to carboxylic acid, it is a mild oxidizing agent. But something which converts primary alcohol to carboxylic acid directly, that is strong oxidizing agent. Secondary alcohol to ketone. Clear? Then there is one more. that is K2Cr2O7 in the presence of H2SO4. It is a strong oxidizing agent, strong oxidizing agent, strong, it is strong. So these are the list of the oxidizing agents you have to remember and that flow chart which you have to remember. Let's talk about the reducing agent also. Let's talk about the reducing agents. So everyone knows about this reducing agent, hydrogen in the presence of platinum, palladium, or nickel. Okay. Then there comes, I'll write mild reducing agent. Then there comes sodium borohydride. This is also a mild reducing agent. Means if I start from a carboxylic acid, if I start from a carboxylic acid, carboxylic acid will get converted to aldehyde. And if I start from aldehyde will getting converted to what? Primary alcohol. Okay. Same way for the second one also. Same way for the second one also. That is carboxylic acid will be reduced to aldehyde. And if you apply it on aldehyde, it will get converted to primary alcohol. Okay. Same way is like our sodium in the presence of ethanol. This is also works in a same manner. This will also work in a same manner. Okay. Fourth is dibal H. Dibal H. Full form diisobutyl aluminium hydride. Okay. It is like this. This is isobutyl group and there is a hydrogen. This is structure of this. This is methyl, this is methyl, and this is methyl. Yeah, this is structure. This is also a mild oxidizing agent. This is mild, sorry, not oxidizing, reducing agent. But it has the capacity to reduce, um, many functional groups through aldehyde. This is diol H. There is one more reducing agent, fifth, SnCl2 plus HCl. This is also a mild reducing agent, mild. And sixth is lithium aluminum hydride. This is strong. This is strong. Means you have the carboxylic acid, you have the carboxylic acid. This will convert it to primary alcohol. What about the aldehyde? What about the ketone? If you apply this reducing agent on ketone, only one option is there, that is secondary alcohol. So we'll take one example how the questions could be asked based on this type of reaction so that you get to know how to apply all the tricks which we have studied just now. So here is the question. Question is convert butane 1-ol to butanoic acid. Like butane 1-ol is primary alcohol if I write it this way. CH3, CH2, CH2, CH2OH. And you want to convert this to what? Butanoic acid. That is this, right? So this is basically oxidation. Now there are two possibilities or many possibilities, what you can write as the this is oxidation. So what oxidizing agent you are going to use? Are you going to use a sodium borohydride? No, because sodium borohydride is a mild oxidizing agent. It will oxidize only up till what? Aldehyde. Can you use this sodium in the presence of ethanol? No, because this is also a mild, sorry, this is a reducing agent I am speaking, right? Sorry, not this, not this. Oxidizing agents like, CrO3. Can we use the oxidizing agents like CrO3? No, this will oxidize it up till aldehyde. Okay. Can we use Jones reagent? No, because it will oxidize up till aldehyde. Can we use KMNO4? Yes, we can use KMNO4. Better if we use it in the acidic medium directly. You will get converted. We can convert primary alcohol to the what? Carboxylic acid. And if the compound is butane 1-ol, same compound you need to convert to a you know butanol. Let's say this butane 1-ol. This is butanol, and you want to convert this to butanol. You can use any oxidizing agent. Any means any, except what? Except KMNO4 or K2Cr2O7. You can use CrO3, you can use CrO3, or you can use PCC, or you can use Jones reagent. Okay, you will get marks for this because this can oxidize it to a aldehyde. Further, convert propanic acid to propane 1-ol. Propanic acid is this CH3, CH2, COOH. You want to convert this to propane 1-ol. This is basically a reduction. If you see the flow chart, it is reduction. And for this, you will have to use a strong reducing agent like lithium, aluminum hydride. Other reducing agent you cannot use. But if there is a compound like this butanone, if there is a compound like this butanone, and you want to convert this to butan to all, you can use any reducing agent. You can use lithium, aluminum hydride, or sodium borohydride because it will anyway give you what? Just one step, no? That is ketone to aldehyde, or you can use sodium in the presence of ethanol, or you can also use hydrogen in the presence of platinum, palladium, or nickel. So these are the application of those that flow chart, whatever we studied. So this is the major hack which you can use for your preparations of the alcohols, phenols, ethers, and the aldehydes, ketone, carboxylic acid. These are some of the common and the major reactions. Many times, one or two questions come on this only. If you know this, your alcohols and aldehydes, ketone, carboxylic acid will be sorted. Thank you very much, and please don't forget to like, share, and subscribe. Bye.